Hello. In this lesson we will be talking about transforming the graphs of trigonometric functions using some of the properties that we have learned before. To do this, we're going to use a website called Desmos, which is a very useful tool for working with graphs of functions. Okay, so here we are on Desmos. Let's first define a function, f of x equals sine of x. And we're going to use this sine x function to show you how transformations of these graphs work. So the first thing you might want to do is shift this graph around, or translate it, which is the technical term. We want to transform this function, and to do that, what we can do is we can just add a constant to the end of it, say 1. This will shift our graph upwards by 1, since we're just adding 1 to each of the y coordinates of this graph. Or, alternatively, we can write this as f of x plus 1. You can see that that shifts our graph up by 1, just the same as adding 1 to the end of sine of x here. In general, if you add f of x plus a, where a is some number, that will shift the graph a units up, or if the a is negative, a units down. You can see that if we move a around here, that's what it does. To translate the graph horizontally, what you're going to do is you're going to replace by x minus a, where a is some constant. And what this is going to do is shift your graph a units to the right. So as you can see, as we increase a, the graph shifts right. As we decrease it, it shifts left. In general, f of x minus a is going to do this for us. We can also stretch this graph in both of these directions. To do this, we're going to multiply the function by the factor that we want to stretch the graph by. As you can see, stretching the graph in the y direction changes its amplitude without affecting its period. And stretching by a negative number reflects the graph in the x-axis. We can also stretch the graph horizontally. This is a bit different from stretching the graph vertically because we multiply the x by our constant a, but this is going to stretch our graph by a factor of 1 over a. As you can see, as we increase a, our graph actually shrinks, and as we decrease it, it widens out. And if we go negative, what actually happens is the graph gets reflected in the y-axis.